Another very common mechanic in many games will be the use of some kind of health system. And as I wanted this to not only be available for a set range of classes such as our characters and enemies, I've approached this setup with the use of interfaces so that we can easily extend this to things like props and objects around the world to open up the opportunity for that more emergent gameplay. So for this, the class setup is actually fairly simple, so we can jump straight into our code files. I'm in the header at the moment for the health component, and we can take a look at how this works in the editor afterwards. So it's a standard actor component. Again, we're not going to need any of that transform information, so the choice has been made specifically to make this an actor component. We have a couple of variables down here. We have our default health and our health, so we can set a minimum, and then obviously we can then track that health value as we go through. And I've made the default health editable anywhere so that we can change this in the editor, and we can also update this through our blueprint if we needed to. The health value is going to be purely relevant to the class here, so we don't need that to be accessible, but by making it blueprint read-only, we can check on that through blueprints if we ever did need to query how much health is left on our health component. Then, of course, you've seen this already. We've got an actor named owner, which we're going to set to null pointer, and this will be the actor. This is placed on later. And then finally, we've got a custom take damage function. The overrides here are specific as we're going to be binding this to the take damage functions already implemented in the engine. So over in the code file, the way that this is going to be set up, we've got the default health being set to 100 in the constructor just here, just so that we have a value of some sort. You can do this through the editor, or of course we could have set this up in the header file just here, but I've set these to be 0. Then moving down to the begin play, we're doing the important things. When we get into our begin play function, I've put the owner equals get owner here, so we're setting that here. Because we want to do our binding, or we can only really do our binding in the begin play or the take damage. So what we're doing is we're binding our custom take damage function that we will be implementing just below. We're binding that to the on take any damage on the owner. So again, this is a standard function that any actor class will have, and we're just binding it with the same overrides, which is where this signature just here is coming from. That is relevant to the take any damage function. Again, just in case you're not familiar with the way that we're doing the binding here. So that's how we have the dynamic binding set up. And then finally, we're going to set our current health to be whatever the default health is. So we now have our starting point. We have our full health. When we enter the begin play, we have bound our take damage function to the on take any damage on the owning actor. So again, this is going to be very universal and reusable between different classes. And then finally, for the take damage function, we're just using a clamp to make sure that we don't go outside of the minimum of 0, so we don't go into negative health values, and we don't go past our maximum default health value. So that kind of thing is optional, but this just allows you to avoid weird kind of use case scenarios or allow cheating to get the health going up to a kind of infinite value. The important thing is when we're tracking our health, so when this is being passed in, we're passing in the damage float, so we're going to take that away from the current health just here. If, as we're going through and tracking this, if our health is less than or equal to 0, and again, this is just a personal preference, you could easily just say equal to 0, as of course we're clamping this just above. But just in case the code ever changes, we're just going to include the full check here, as pretty much anything which is less than or equal to 0 would equal death, usually. What we want to do is check if the owning actor is implementing the health interface. We're doing that with a simple cast to the iHealth interface on the owner. Now, what you probably want to do here is to add an if check here, as I've done below, but also provide an else statement to provide an error or warning message, because the way this is set up and intended to be used, the health component will not work if the owning actor doesn't have a health interface implemented. So this, again, just allows us to very flexibly work this with anything. We don't need to cast to specific actors to check if it's a character or something which has the ability to take damage. Like I've mentioned, we could place this on a tree or a fence or a vehicle, and they could all take health in their own way. So Once you've depleted the health on a vehicle, it would blow up. Once you've depleted the health on a tree, it will fall down and provide logs. So this is the way that this has really been intended, which is why working with this kind of interface system allows you to drop the interface and the components on anything, and then let them do their own custom stuff when they reach that health 0 value. So ideally, I've left this out for readability, but you could drop down here, add an else statement, and like I said, if you find that this check returns false, then just pass a warning or an error to say that the owning actor doesn't have the health interface and it's needed for this to be executed. And what we're doing, so if we have found an interface, then we're just calling the execute health depleted function through that interface on the owning actor class. And we have looked at this very briefly in another module, but I'll just go back and show you this one as well. So remember, inside of the health interface, this was the function I've mentioned, that we don't have a function created in our code file. Instead, we just create the declaration of that function in our header, and then in our actor class, when this function is implemented through the interface call, remember that was just calling the destroy function. And again, that's going to be relevant very shortly in the next module when we look at how the destruction is working. So hopefully this is all coming together though, and is going to make sense, because now we know that when the health is depleted, that function is being called on the demo actor. The demo actor is being destroyed, and basically the destruction component is bound to the onDestroy function, which is how we're going to play those specific destruction related effects and carry that out before the actor is removed. So back in the health component, these are the very simple setups. You can see no extra considerations have been made for attaching or detaching other components, because that's not relevant to the actor setup or the actor component setup compared to what we've seen in the homing component setup. The only thing I have done here, and again this is very, very important to remember, is because this doesn't need a constant tick check for the health, I've removed the tick function and ensured that we've set the B can ever tick to be false, because like I've mentioned, if everything can potentially have a health component in the world for that kind of full flexibility, we don't want all of those actors or all of those components doing their component tick. Then back over in the editor, just to show exactly how this is working, like I've mentioned, we don't need to do anything in the blueprint. The option to override or implement the health depleted function is here if you wanted to do something with that in blueprint. I haven't needed to, we've just left this purely C++ for the examples. So just to show you that the blueprint class is completely empty, besides those components that we've added onto the class. Now, what we do need to look at is in the player class. So the way that this is working is just a kind of reworking of the default first-person player shooting system, which is why it still says spawn projectile. We won't be using that anymore, we're just using a line trace. We're getting the location to trace our line, which is basically forward from our crosshair. And when we find something, if we hit any actor, so again, this is very, very flexible. It doesn't need to be another character. It doesn't need to be a destructible actor or something. We're not specifying it to that level. We're going for full reusability and flexibility here. So if we hit anything at all, we're going to apply damage, applying a base damage of 50, and of course, adding a handy print string in. So what this means in reality is if we come in and press play, this is, as you can see here, doing all of this, we're actually hitting the floor and we're applying these 50 units of damage to the floor. Now, of course, this doesn't matter. It's a very cheap call. That damage is just being ignored because the floor doesn't have a health or destruction component. In comparison, though, all of these do. So when we hit these, after a certain amount of damage is applied, you can see these are going to be getting removed. They're only getting removed because of, or they're only playing the particles because of the destruction component, but they're getting removed because of that function call in our demo actor. So we're just going to go back and look at that quickly. And basically just remember a recap here of our health depleted. When that's called, we are destroying this. So that's all the health component is doing. So if we didn't have the destruction components on, all these would be doing is just disappearing and not playing the particle effect or anything like that. And another thing, of course, with the health components is we can come in and give them all different values. So this is why we've exposed this. So we could make the cube on the end just take one hit until it dies or is removed. The middle one could take the full 2 hits, so leaving that at 100. And then this one we could set to be 300 or something, or 200, so it takes those extra hits before it's removed. Now, it's something that we kind of have as a carry on over here from the previous modules as well, is because some of these would have had components manually applied to them, you will want to come in and make sure that they have only one destruction and health component on these, the ones which are inherited. So you may want to go through all of the different actors that you have and make sure that they only have one of each type of component on them. Since we've gone through and made that change to add them in the code so that every version of this class will have one automatically. But with those changes, just to say very quickly then, we can see this one takes 1 hit, this one takes 2, and this one should take 4. So that's all working as intended. I'm going to need to go back through and add the different variables back to our destruction component, but actually that gives me a perfect opportunity to go through all of that in the next module when we look at our new component. Now that we've seen the implementation of the health component and how it's tracking the health value, linking that to the owning actor, we're now ready to dive in and see how the destruction component is working on top of this to play different effects and provide different responses depending on the settings the destruction component is given to each of the different actors that they've been placed on.